Hello guys, welcome back in the part 2 of Xilinx Vivado Design Suite walkthrough. So we have left our first part here. We created the file, but first we need to go through every options in this interface, right? So here we have the first fundamental thing is the flow navigator. As name implies, like it controls all of the flow of your project. Okay, so it does have a project manager. Okay, so you're seeing like in the project manager we do have a settings option. Okay, if I click on that, so what's gonna happen is like it's gonna show me a pop-up window of settings. Okay, in the settings tab, you can see there is a name of your project, your device, your target language. That's all the settings that we have set initially when we were creating the project. Okay, and in the language options, you see, I mean, in this Vivado, it is still it's using the Verilog version, which is Verilog 2001. Okay, all right, that's the general setting. If you go in the simulation settings, you can see like, okay, the target simulator is the Vivado simulator itself because the Vivado, it does have its own simulator. But you can see if you just open up the scroll the 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 down list, okay, you can see like there are other simulators as well, like the Vivado simulator, Model Sim, Covista Advanced Simulator, Riveria Active HDL, etc. Right? So the simulator language, as I have recommended already, you should have the mixed instead of just the VHDL or the Verilog. Or you can specify if you are sure, like you're just gonna have the Verilog or VHDL files. Okay, the simulation set is just we can have more simulation sets, but it's you can understand like by the time what it is actually. All right, the simulation top module name is the example. So I'm not gonna give you a lot of explanations here because by the time I will tell you on every step like what everything, uh, how everything it works, right? So in there are like a lot of tabs here in the compilation, the elaboration, simulation, net list, advanced. So they do have like a lot of options inside the tabs. Like that's the XSim, which is the Vivado simulator, simulate dot runtime. So that's the simulator is a property, and then runtime is the property of simulate. So you can set the times like how long it's gonna simulate your design. Okay, you can change this guy like 1000 nanosecond or maybe just 1 millisecond or whatever. Okay, in the elaboration tab, you can see like XSim elaborate debug level is typical. You can see like all or on or off, but it doesn't matter at this stage. So just skip this guy, and in the compilation, I don't see anything to explain here for now. So I'm just gonna skip this part as well. I mean, by the time we will show everything time to time, like whenever we need it. Okay, in the elaboration, you can see specify various settings associated to elaboration, link IP model option, black box model, netlist option. It's very hard to explain everything at this point because we really don't have any project or any IP or anything. So uh, I'm just like giving a real top level things right now. So once we do stuff, then we can go through whenever we need these options. Okay, in the synthesis you can see like the constraints. Right now the constraints set is constraints underscore one, which is kind of active, but we don't have any file in there. And in the report options we have the strategy, and you can I mean that's the default reports. But if you just open the drop down list, you can see like no reports or user defined report strategies. Right now that's the default, so keep it default. If you select no reports, it's not going to generate any synthesis reports. And when we say reports, we will see like what are the reports and how the reports are generated and how to read it and why are they useful or not useful. Everything we will see later. Okay, in the options, these are all options. I will explain it later when we specifically we will be discussing synthesis and implementation and everything. There's more like the strategy thing. So what are the strategies? First you need to know that. So right now I'm just gonna skip this part as well. And in the implementation, that's the same thing, and we will discuss when we are implementing some design. Then we will discuss like how strategies work and what are these options and are they useful for us or not, and how to set them. Everything we will see. Okay. And in the bit stream, it's more like the same thing because that's the flow. So we are having same kind of options here, and we will see like how to set and how to get good out of them. Okay. And that's the intellectual property IP. If you just click on this, that's the repository and that's the packager. And this is also the next stage thing, so I'm not going to discuss at this fundamental walkthrough. Okay, and that's the tool settings. Okay, so that's the project, like last project's directory home, and that's the IP defaults board repository where the board file is located, source files in the display, and web. That's not the good option, I guess. And there's the help text editor, third party simulators, colors, and a lot of things. Like you can just go and just, I mean, for me it's these are not that important. Okay, so I, because I didn't change anything, so doesn't matter I apply or I cancel or I just click OK. So that really doesn't matter. And the second option in the project manager tab, that's the project manager tab, that's the add sources. Okay, so if I click the add sources, if you remember in the first part, that's more like the same pop-up window. Right here, add sources means like you can add three type of sources. Right, you can add or create the constraints file, like I said, like whenever you have the pins package information, when you are going to define the timing exceptions, timing, um, everything related to your clocks and multi-cycle paths and false paths, all they're gonna be in the constraints file. Okay, and if you're gonna add or create the design sources, it means like you're gonna create the Verilog file or the VHDL files or the system Verilog files. I mean, whatever the source file it will be, you are gonna add through this guy. Or add or create a simulation source file. You can definitely think like what are the differences in these two options. Okay, so these files are particularly for the simulations. They are not gonna be in your active design sources file. That's the another kind of, that's the simulation sources. So it's more like the simulation file. Sometimes we do have memory initiation files, and I mean, for the simulation, we will have the test bench file. So that's gonna be in this option. Okay, so it's more like the same thing like we have seen already. So if I click on add or create the design source file, it's gonna give me the same thing like add file or create file. Once I'll add or create it, it will ask me finish and everything like that. Okay, so that's the same thing like we have seen already. Okay, that's the another good option, which is the language template. So if you are really new to this software like the Vivado Design Suite, or you're just learning Verilog or VHDL, you can go through this language template, and you are seeing here like in the templates and the preview, the things like if I just click on Verilog, that's the command construct. So if I click this and then that, and if this guy, so it's gonna give you a very fundamental syntax like how you code any design, like if you are seeing like under the comment section, it's giving you the information like how you can have the multiple lines comment right in the Verilog, and that's the sample header file. Like you, if you are designer, you're gonna give information in the file like you are the author, what's the date of the creation of the file, and what's the target version, and what's the module name, description about the module, a lot of stuff, right? Single line comment is just that. Okay. In the compiler directives, you can see like how you can define and if def and def, else if else, and if and def info, everything. So that's the language template, and you can see a lot of in basic information. I'm not saying a lot of real information. I mean, it's a real information, but it's just the fundamental thing, right? So if you are just kind of learning Verilog, you can just come here and just double check the syntax, like whatever you are trying to do, it's good or not. If you are seeing errors, you can just copy this syntax and paste it, and then you can go through that. Okay, so a lot of syntax things like Xilinx parameterized macros XCM. In the XCM, you can see the CDC thing, the FIFO memory, everything dual port, and it's a lot of times I use this XPM memory and XPM FIFO. Why? Because it's kind of easy just to copy paste in your design, not the whole thing like the comment section, but here the instantiation part, right? So it's very easy, like just copy control A and then just paste into your file wherever you are going to instantiate your memory or your FIFO or your CDC thing, right? So in next couple of videos, we will learn how to code things in Verilog, right? Then we will see everything like we can use some stuff from here, okay? And the same thing in the VHDL and in the system Verilog, and that's the XDC, and that's the debug stuff. That's very interesting. I really like it, and uh, later on we will see like how to debug things. Okay, so for now that's the language template, so I'm just gonna close it. And then that's the IP catalog. IP catalog is basically, that's not a pop-up window. If you notice, it's just open up a tab in the project manager, like the project summary. That's the one window, project summary, and you see all the information that you have specified when you were creating the project name, directory, and that blah blah blah. And then in the IP catalog, you're seeing like there are a lot of options. You can search it directly if you know the IP name. If you don't know, then you can go through one by one, and whatever you are gonna use, you can just use that IP. I will show you like how you create the IPs and how to use them and every stuff, right? So that's the option to create the IP. That's the IP catalog. Okay. All right, the next thing is the IP integrator, right? That's for the block diagram. Like if you are gonna working on system on chip design, you're gonna have a block diagram, right? So if you are gonna work on that, you can create a block diagram. It's more like the same thing, like you just created a file, like the design file, but the design file is the file that in which you are gonna code, right? But the block diagram is not the same as your design file. Is it is a design file, but you are gonna create the block diagram. And when I say block diagram, it's more like a system on chip block diagram. You're gonna add the processor, the memory block, the DMA, or the other stuff, and then you will create a wrapper for that and everything like that. Okay, but for now, I'm not gonna create a block diagram, so I'm just gonna click on cancel for now because I don't have any block diagram. So the open block diagram option is disabled for now, and generate the block design, because as I said, I don't have any, so it's not gonna generate any. So these two options are disabled for now. Okay. All right, the third option in the Flow Navigator is the simulation, right? So if I have any file in the simulation, if I click on that, then it's gonna give me, and I didn't click like I didn't do a right click. I just click like the left click, right? And it gives me that option, run behavioral simulation, and we will see what is behavioral simulation, what is post-synthesis functional simulation, post-synthesis timing, post-implementation, functional and timing. There are like five options to simulate your design, but that's the easiest. That's the easiest one, and the first, the first simulation you are gonna do. These guys are like, once you synthesize your design and then you are going to simulate your synthesized design with your current test bench, then you are going to use these options. And once you implement, and then you're going to use again the same test file with your implemented design, then you're going to use these two options. So that's the first option, without having any synthesis or implementation, just with your RTL code. Okay. So this is the simulation, how and how we do it, we will see it later. Okay, and that's the RTL analysis. What is the RTL analysis? RTL analysis is basically, it's gonna give you the basic idea of how your design will look like once you code. For example, you are just coding a register which is called a flip-flop, right? So it's gonna give you a general diagram of the 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 register or the flip-flop. Okay, because I really don't have anything right now, so for now I cannot make a schematic or generate a block diagram here. So it's just the RTL analysis, like it analyzes your RTL. If there are like a syntax error or anything else going wrong, it will tell you. So you can generate the report methodology here, or report DRC, right? DRC is just the design rule check. Okay, so that's the RTL analysis. Normally, I don't use it a lot, but sometimes I do use it for, just generating the schematics for my code, like what it will be. But the thing is, like, Vivado is really a smart tool. Whatever you are gonna see here, it's not gonna implement your design at the same way. Other than that, it is actually optimize your design a lot, right? So it's a very, basic analysis at this point. Okay, the next thing is the synthesis. Synthesis, the same thing. Right now, we don't have any design, so this option, open synthesized design, is actually disabled, but this guy is enabled. But right now, we don't have any design. So if I'm gonna just click synthesis, it's gonna ask me like, okay, so are you gonna launch the synthesis on your local host? Local host is like, I'm kind of working on my machine. I don't have any servers, right? So that's it. Number of jobs, like how many runs is gonna run in parallel, right? And when I say number of runs, it means like if I do have more than one synthesis strategy. Okay, and the launching directory is basically, you're gonna launch the synthesis in the local default directory, or you're gonna specify any location, like whatever the synthesis will generate the files where they are gonna store. Okay, so for now I don't have any, and that's the generate scripts only. It means like it's gonna give you some scripts, probably tickle based scripts, which means like it's not gonna start the synthesis, but it's just gonna give you the scripts, like you're just gonna generate the scripts. And when I say scripts, it means like whenever you are gonna synthesize your RTL, your design, what Vivado does is basically it generates the tickle scripts, and then that tickle scripts are gonna used by Vivado itself, like step by step things. Like initially, it open up your all the files, and then read and elaborate and link and everything like that. Okay, we will see like how I will show you later on when we will like synthesize any design. I will show you like how the scripts look like, and what we can do, but definitely we cannot change it. If we can generate it, right? But if I'm gonna launch it, we cannot change the scripts. Okay, All right, so if you just click on that, it's not gonna show you the dialog box again, but I'm not gonna do it for now. I'm just going to cancel it. And that's the implementation, right? Implementation is basically the synthesis is just, I mean, we will discuss like what is synthesis later on, but synthesis is just like it's more like a converting your high level design into a gate level design. Okay, and then the implementation is like all the gate level design, right? They are gonna place on your device, and then they will be routed, right? And then you can generate the bit stream. So that's the implementation. So implementation is basically the placing and the routing thing, right? Right now we don't have it, so this option is disabled. And then the last option is program and debug. Program means like once you have done with the implementation, you're gonna generate the bit stream. And when I say bit stream, it means like there is a file which contains probably just one or zeros for your device. Is gonna be in your device, and it's gonna connect all the elements like the transistors and everything, flip flops, and LUTs and memories, and everything is gonna be connected through this file. And then whatever you design, they're actually gonna work in that way. Okay, and that's the hardware manager, and this is the same hardware manager that I have shown you in the first part of the video. And this hardware manager is basically is used for to download the FPGA image, which is your bit stream, into the FPGA, the real device, or the, because as the name implies here, debug. It means like if you have any ILE core or the debug core instantiated in your design, now you're gonna open up the debugging stuff through this Vivado hardware manager. Okay, so that's the basic thing. You can, if you just you don't want to say it, you can just minimize it, but I don't recommend it, right? Okay, so that's the another thing I have already told you. That's the project manager. It does have all this small windows, right? That's the sources, and there's the project summary. We have discussed this project summary. Right now in the project summary, what we have are the settings, the board part information, okay, and the synthesis and implementation information, DRC violations, power, right? Synthesis, because we haven't done anything, so you are seeing like the status is not started, no errors, no warnings here, status is not started, nothing, right? And there, because we don't have anything, so there's no violations, no timings, no utilization, no power. Utilization means like how much resources you are actually consuming in your device, and the power, like how much power is gonna take or is gonna burn. And the timings are like if your whatever the critical paths in your design are they meeting timings or not, or I mean, is there any negative slack or a positive slack? And the DRC violations, like if you design in that way, like in the placement you have placed something, I mean, you are not gonna place, Vivado does, but the thing is like you deliberately do something which is against the DRC rules, then it's gonna have the violations. But I never seen this violations a lot, but you can probably see just to make an experiment. Okay, and that's the most important section, right? That's the most important section. But before explaining anything in there, I think I skipped this part, but I shouldn't. So that's the sources part. If you see in the sources tab, you can see like there are the design sources, right? We have added one file, and that's the constraints we have been talking about, right? Two times. So that's the constraint, these are the sections, right? And these are the active directories, right? And in the simulation sources, we have a directory called sim_1, and it actually, this is the same file, but it is showing me like this file is also under in the simulation, right? Once we instantiate in our test bench, then it's gonna be under the new file, right? And that's the utility resources. Right now we don't have any, so that's okay. So let's go back to the this tab, and in this window we have like five tabs. So the first tab is the Tickle Console. So Tickle, or the Tool Command Language, TCL. So in this command window, the thing is like we have more like a command line, right? You can type the Tickle command, right, to execute any of the functionality in the Vivado, right? Like initially what we did, we started the Vivado. So the first command, actually we didn't write it, but the thing is like in the Tickle Console, Vivado actually is recording kind of everything what we click. So behind every option there is a command. So when we double click on the Vivado icon on our desktop, it basically it actually started this command, start GUI, and then we created a project. So it actually it wrote a command like create project and the name of the project, the location and the part, right? We can do it manually, like we can write it. I mean, if I just start the GUI and if I write this command, it's gonna create the same exact project. And then we set the property dglandinc.com and that, and then we actually created a file. So you see file mkdir, so it created a directory, right? D projects, project one, project dot this, and as I said before, srcs, it created a directory under the project dot one, and then in that there is a sources one directory, and then the new, and in the new it created a file. I know it's more like a little complex here, but once you go through it, you will understand like it's not a very rocket science. It's just a very easy thing to understand, but you don't need to write everything. It's, as I said, it's just a console. So whatever you do on the interface, like on the GUI, it actually behind your click, it's basically a command, right? Okay, in the messages tab right now we just have the information, right? I can hide all of them, I can show all of them. So right now, because we didn't run any synthesis or RTL elaboration or implementation or anything, so we don't have any warnings, critical warnings, errors, or DRC violations, nothing. Just the information like, okay, refreshing IP repositories, no user IP repositories is specified, that blah blah blah. And in the log tab right now we don't have anything, but if you notice in the log tab we do have, I mean, that's the tab and that's the sub tab, synthesis, implementation, and the simulation. If I'm gonna synthesize anything, Vivado generates a log like how it is doing synthesis and everything. And then once you start the implementation, this sub tab will have all the logs. And in if you are just simulating the design, the simulation will have all the logs in here, right? In the reports right now, everything is there is no kind of report, but what you can see is in under the synthesis you can see like it's gonna generate the utilization report utilization, the timing report under the implementation, the report DRC, report timing summary, report utilization, control sets, incremental use. There's a lot of things, right? I mean, methodology, power, out status, clock utilization, bus skew, everything. But we will see uh, whenever we need to review these reports, I will show you like how Vivado does generate these reports and what are the information inside these reports, and how that information useful for us, and what should we do with these reports, right? And that's the design runs, right? That's the tab that has all the runs, right? So that's the default, like synth underscore one, impl underscore one. So that's the default. But what you could do is like you can create more runs, right? And yours, maybe you are thinking like, why do we create more runs, like we do have a default runs? Okay, so that's the thing. If you if you see this tab, right, that's the name, that's the constraint sets, right, that's the constraint set. Like this is the same thing here. If you specify any file in the constraint set, this run is going to use that file. If you have more than that, you can change it so you can have more runs, right? That's the status not started, that's the WNS, TNS, WHS, that total power, failed routes, LU2, all the information will be here once you synthesize any design. And that's the main part. So run strategy. So run strategy is like right now that's the default strategy for synthesis and default strategy for implementation, right? But if you are gonna create a new run, you can have more strategies here, right? And that's the report strategy. If you remember, we saw it already in our settings, right? That's how Vivado create the reports, right? And that is a part. Like this part is basically the same part. Like we selected in the start, and that's the just the description. Okay, so that's the important thing, right? So for example, if I'm gonna create a run, so it will pop up a new window like you are going to create the run for synthesis, for implementation, or for both. So for example, I'm going to create a run for synthesis for now just to show you. So it's going to just increase the index by 2, and then the constraint set you can select. Right now you only have one and no files in that, but you can select the other constraint sets, right? And you can even change the part number. It's more like a tricky thing, so just skip for now. And that's the run strategy, right? So the run strategy, that is the most important thing, right? I mean, which strategy you are gonna select. So you should know like which strategy does what. So for now I'm just showing you like you do have other strategies. And why we have a lot of strategies, because sometimes one strategy doesn't meet timing, right? And because the strategies are for different algorithms for your synthesis, and different algorithms for your placement, routing, and everything, right? I mean, if your design is really complex, a lot of resources are going to be used, then your design will have congestion or routing problems. So in that case, we can have actually different strategies to meet timings, right? I mean, all the critical paths. And that's the report strategy again. You can select default or no reports or whatever, and you can make it active, right? I mean, if right now that is the active one, but you can make this strategy as active. I'm not going to create any strategy because right now I don't have any file, but later on in the next couple of videos, once we will have the project, we will show we will make an experiment to add the other strategies and try to run all of them in parallel and everything. So that's the thing in the design tabs, right? So I think that's okay for this video. In the next video, I will show you how you start with the very basic like editing in of the file, right? So keep watching. All right, thank you.